So that was the force that's required to raise a load or apply, do positive work is another way to think about it, or to clamp on something, because we're talking about power screws in general. It can be used not just for clamps, but actually, doing work, pushing something around, kind of like a hydraulic piston. You can use hydraulic screws to convert, or screws in general to convert a rotary motion from an electric motor or some sort of motor into a linear motion, so that they can work kind of like a hydraulic cylinder would. We also would want to find, in some cases, what torque is required to lower the load. You think, oh, well, you've got something pushing on this, right? Well, why doesn't it just go down? Well, there's friction that's kind of keeping it in place. However, it does require less. If I'm going to push on the bottom here, it takes more torque to push my finger up than it does to lower my finger. That's certainly true. So let's figure out what torque is required in order to overcome the friction when I'm pushing down on it like that. And I'm trying to lower it. So what's going to change about my free body diagram is that the friction is now going to, well, my torque is going in the opposite direction. That's certainly true. So this is going to be in the opposite direction. So whatever I have over here, wherever I have had an FT, I'm going to make that a negative FT basically. That's kind of going to manifest itself by, I could say, if I've got a negative FT, that's kind of like having a negative torque here. So the thing that I'm solving for is kind of like negative torque. That's the only change I really need to make, because that's the only place that FT showed up in the equation was on this side, right? I had FT over here, so I'm just kind of making the left-hand side negative. This is just a quick way of generating that. You can go through this whole process again if you'd like, but this is a quick way of seeing what the answer ends up being and why. And also this friction force is going to act in the opposite direction. So I've drawn the arrow this way, but wherever we see a mu n, we can make that a negative mu n over here. So then I can remember, mu never gets separated from n. So wherever I see a mu, I can basically turn that term negative as well. And so we're going to have f dm over 2 L minus mu pi dm over pi dm plus mu L. And we wanted the torque required to lower it. We don't want the negative of the torque required to lower it, so we can bring this minus hand to the other side. And that you can write it as having the effect of flipping this top term here to mu pi dm minus L. And that's the torque that's required to lower it. So that is one way of generating that.